Hey, math followers, Mr. Choose here with Tray Arithmetic Plus. That means it's pre-algebra, which means we're throwing some variables in there. Let's talk about greatest common factors, finding them using primes, and factoring it out of an expression. If this video helps you, give it a thumbs up. Like the video. It helps me push it out to more people. Subscribe to my YouTube channel. There could be a button down here if you're on your computer. If not, it would be underneath the video on your device. I gave a lesson that there'll be a link to at the end up here if you need to see more examples and more explanation. And then these are the two challenge problems. So in challenge 1, we want you to find just a regular GCF of 3 numbers. In challenge 2, we want you to factor a GCF out of an expression. So I went as far as to show you the factor trees, so I'm going to do it again. The factor trees allow you to come up with all the primes. So 15, 45, and 60 will be listed here, and we'll list all our prime factors. So 15 is 3 times 5. So I'll list those 2 primes. And you can multiply across to verify that that indeed is the right primes. This is 3 times 15 and 3 times 5. So it's 3 times 3 times 5. 3 times 3 is 9 times 5 is 45. That verified that yes, indeed, that did work. 2 times 30, 2 times 15, and 3 times 5. So 2 times 2 times 3 times 5. 2 times 2 is 4, times 3 is 12, times 5 is 60. So these 3 factor trees just allowed me to quickly write all the primes. Next thing you do, you circle the common factors. So it has to be in all of them. I can't circle 3, 3, 2 because there's not a 2 in the first 2. But look, there are 3s. Even though this is coming down at an angle, that doesn't matter. As long as it's in all of them, which means it's common. And then the 5s also are common in all 3. So the GCF, I might have to buy me some new markers. These are not writing very well. Is 3 times 5, which is 15. And I did have a student tell me once, they said, well, look, Mr. Chu, there's a 15 here, and a 15 here, and a 15 here. And yes, that is an alternate way to do it. But it's harder when it's got X's in it. And that's what we're trying to get everybody ready for in arithmetic and pre-algebra, is to do it in algebra, geometry, algebra 2, pre-calc, and calculus. So challenge 2 says factor the GCF using primes out of this expression. Very first thing I want to do, because it can cause a problem, is change the minus 36a squared b to plus a negative. And I've done that in earlier videos because students will leave off the negative sign. And if you do, it means you missed it. All right, so just like we did here, let's use factor trees on these terms of this algebraic expression here. So 9 is 3 times 3. A squared is A times A. And B cubed is B times B times B. So I've got 3 times 3. A, B, B, and I've got a third B there. And because that third B is going into my factor tree, I'm going to just erase this factor tree and get it out of here because I already have my factors, which is what I need. All right, now we go to our 18a cubed b squared. 18 is 2 times 9, and 9 is 3 times 3. My a cubed has 3 a's as factors. My b squared has 2 b's as factors. So that's 2 times 3 times 3 and then A, B, B. Now, since I have my factor tree, I'm just going to erase it and get it out of there. Now, my negative 36 A squared B. That one is a little bit different because you have to first factor out the negative 1. And then times 36. Then your 36 is 2 times 18. Your 18 is 2 times 9. And your 9 is 3 times 3. And then we have 2 A's as factors and 2 B's as factors. So I can't forget my negative 1. And then we've got 2 times 2 times 3 times 3. And then we've got A, B, B. Now, just like I did, I'm going to erase this factor tree to get it out of our way. And now let's just double check and make sure we have the prime factors right. 3 times 3 is 9. That's 9. A squared. Yep. B cubed. That one's right. Black one's right. Now the blue one. 2 times 3 is 6. Times 3 is 18. That's right. Then we got A cubed. B squared. Negative 36. Negative 1 times 2 is negative 2. Times 2 is negative 4. Times 3 is negative 12. Times 3 is negative 36. That's right. And we got A squared, B squared. You remember the next step? And this is the one that's a little bit confusing because there's so many numbers here. We've got to circle what's common in both of them. Well, you see these 2 3s, these 2 3s, these 2 3s. That means that both 3s, even though it's really zigzaggedy, can be circled. And then what about A and A? Well, I got an A and A here and an A and A here. So I can circle the first A, and I can circle the second A. And then the B's, I don't have 3 here or 3 here, but I got 2 in both of them. So I circle those 2. All right. Now I'm going to find the GCF. I'm going to put a little check mark here because I'm using that 3. I want to make sure I use everything that's circled. There's a 3 that's circled, a little check mark. This A, this A, this B, and this B. So the GCF is 9A squared B squared. Okay? Now to factor that out, I'm going to take and write this outside of the parentheses. So I write 9A squared B squared. Then inside the parentheses, I'm going to put the items that were not circled. Well, that's 3 circled, A circled, A circled. B is not. B is. So that's just a B. I've got 2. Everything's circled except that A. So it's 2A. I've got a negative 1 times 2, which is negative 2 times 2, which is 4. And you could write that as minus 4. That's some work, isn't it? Took 10 minutes to explain it. The original lesson will be linked up here. We'll have a playlist of other tray arithmetic problems. I'm Mr. Chew, and I want to teach you the math. Keep watching my videos. Give it a thumbs up, like this video, subscribe my YouTube channel, and I'll see you soon.